A tank in the shape of an inverted right circular cone is full of water. The water weighs 62.4 pounds per cubic foot. The height of the tank is 15 feet and the radius of its top is 6 feet. Okay, so let's go ahead and draw a picture of our inverted cone. There's our tank, and it's 6 feet here and 15 here. Now I'm going to go ahead and put kind of a coordinate system to look at here. We're going to put the origin down there at the bottom of the tank. Find the work done in pumping the water over the top edge of the tank. So we know as we figure out work that it's force times displacement or distance, and our force is mass times acceleration. Our acceleration is gravity, and mass, we're going to use volume times density. So we're going to put the density here, and so we need the volume of a slice. So we're going to look at a representative slice here, and if we went around that, we could see it would be circular. And so we need pi r squared. Our r is going to be, as we go across here, let me just get that so we can see across, that's x. And then we've got this distance up to the slice is y. So in order to figure out our x, that's going to vary depending on where the slice is, but we can see that we have a similar right triangles here, and so they will be proportional. So 6 will be to x, as the whole thing 15 would be to the side in the littler triangle there, y. So 6y equals 15x. So x is going to be 6 over 15, which is 2/5 y. So that's our radius. So we need 2/5 y squared. And then we need the distance that we're going to pump. And we're going to the top of the tank here. So to the top of the tank is 15, and then we're going to subtract y, because wherever our slice is, we don't have to pump that water below it, which is y. And then our little thickness for our pi r squared, to make that a volume, the little thickness is the dy. Now we're going to pump, it was full, so we're going to start, we've got to go from 0 to 15 to add up all those little slices for that tank. And we have our water density is 62.4. So as we work this is part A, let's go ahead and we're going to have our 62.4, and we can bring the pi out in front, and also we can square the 2/5 and we can bring that out in front as well because it's a constant. So we'll get all of those things out of the way. And so what that will leave us to integrate, we'd have the y squared, and we're going to distribute that through here. So we're going to have 15 y squared minus y to the third and dy. All right, let's go ahead and do that integration then. And so we've got our constant out in front, and we'll combine all of those, and so we've got 9.984 pi, and then doing the integration, we've got 5y to the third minus 1/4 y to the fourth, and that needs to be evaluated from 0 to 15. So we've got our 9.984 pi. 5 times 15 cubed minus 1/4 times 15 to the fourth. And then our lower limit is 0, so that's 0. All right, so that ends up giving us, as we put that in the calculator, 42120 pi, and the units are foot-pounds. Okay, so let's look at part B. Part B says the work done in pumping the water to a height 15 feet above the top of the tank. So we've got to go up here another 15 feet to the pipe that's going to pump that out. Now, the slice and all the other things stay the same. The only thing that's changing is the distance that we've got to pump it. So if we looked at our original integrand, the only thing that's going to change is this 15 is now going to be 15 plus 15, or 30, because it's 30 up to the top, subtract the y for whatever slice we are. So the rest is going to stay the same, so it's going to have the 9.984 pi still out in front, and the integral is still going to be 0 to 15, because that's the slices of water, summing them all up in the tank, run from 0 to 15. And then the integral itself is going to be, so we had the y squared distributed, would make it 30y squared, and then minus y to the third dy. So in working that one, we still have our 9.984 pi, and then we have 10 y to the third minus 1/4 y to the fourth, evaluated from 0 to 15. So we need to just simply put the 15 in there for the y in both places. I'm out of room, so I won't write that part, but we have basically this stuff out in front, and then times the quantity of 10 15 cubed minus 1/4 15 to the fourth. And when we put that in, we get 210,600 pi, and that is foot-pounds.